So I'll get you to turn to page 4, please. So stopping distances. What we're thinking about here is, well, for a lot of those examples beforehand, you've got maybe a car or some other vehicle in motion, and then it tells you that it decelerates and it stops, for example. And it will do that, but it's not going to start decelerating until you put your foot on the brake. And there is a reaction time between noticing something and actually moving your foot to apply the brake. So in that time, you're actually travelling with constant velocity. So initially, we're travelling at constant . And it depends on the context of the question. And this is the only time where, if velocity then is displacement over time, it's the only time you use this. Because you're often given the velocity in the question, and you're told the time, and then you can work out the displacement, because then the displacement is the velocity times the time. Okay, we can only use this when there's no acceleration. This relationship. We can also think of it, if S equals ut plus a half at squared, when A is equal to 0, S equals ut, doesn't it? Okay, so the equations of motion, the three main equations of motion will always work. But sometimes students get themselves into strife using this relationship here, which only applies when there is 0 acceleration. Alright, so if you think that you can remember then that's fine, but these ones always work. Because we just substitute in 0 and then that removes that part. For our part, this is our reaction time, okay? So this is between seeing the obstacle and then reacting. So now, after that, we can then react, and we'll be decelerating. And we can use our regular equations of motion again for the decelerating part. Alright, so what this means is there's two separate parts to the motion. The first part, travelling at constant velocity between where you see the obstacle and react, and then the second part when you react, and that means that you're going to be braking with a constant deceleration. Alright, so if we look at an example, it says a truck driver travelling at 60 kilometres an hour. So what's the first thing we're going to need to do to that? We need to convert to metres per second. How are we going to convert to metres per second?
Divide by 3.6.
Divide by 3.6. Oops. So what's that number? What is it? What's 60 divided by 3.6?
16.66.
Okay, so we know our initial velocity. Sees a dog run out onto the road 65 metres in front of her. It takes 0.8 seconds for her to apply the brakes. Okay, so this is part one. We're travelling at 16.67 meters a second for 0.8 of a second time it takes to actually react. So we're going to calculate how far the truck went. So how far did the truck travel in that 0.8 of a second?
.36. 1.3. Is it meters?
Yeah, I would have thought 13.3. Just looking at, that's nearly 1.
Oh, I did 0.8. Sorry.
That's all good?
So definitely.
Okay, so the truck went 13.3 metres, seeing the dog in the time it took to put the foot on the brake. Then, part 2, takes a further 2.9 seconds to stop. Well, the initial velocity is still that same. Now we have the time of, what is it? Was it 2.9 seconds? And we know the final velocity is what?
0.
0, because we've stopped. And will she hit the dog? We want to know how far she went. But we can't find that until we have acceleration, or the deceleration. Because our two equations that have displacement also have acceleration. So we're going to need to find that acceleration first. And we can use v equals u plus at for that. So a will equal v minus u on t. A equals 0 minus 16.67 on 2.90 seconds, which according to the booklet is minus 5.76 meters per second squared. Now we have our acceleration, we can find our displacement. 16.67 times 2.90 plus a half times minus 5.76 times 2.90 squared. It is important to keep that negative in because that changes the distance, obviously. So that gives us, according to the booklet, 24.2 meters. Now we do need to remember to add those two values together to find out the total distance. That's going to be what? 37.5? And the dog was 65 meters away. So we have to remember to answer the question. Therefore she didn't hit the dog. So it's not really difficult, but there's a couple of steps to it. Where can you get confused is getting a bit tied up with which time is for what. So that's an important thing, is to just set it out nice and clearly so that hopefully it nice sequential steps for you to follow. Does anybody have any questions about that?